Welcome to the first lecture in the Digital Electronics course, and this course is also called as Digital Logic or Digital Logic and Designing in various colleges. The name is not important, the name of the subject is not important, but the content is, and the content is going to be same, almost same in all of these courses. So you can start from here. We will first see what is a signal, then we will see what is an analog signal, a discrete time signal, and then we will see what is a digital signal, so that we can start our digital electronics course. So let's move to the signal. What it is: a signal is a function that represents the variation of a physical quantity with respect to any parameter. This any parameter is the independent quantity, and it is generally time or distance. So the function is definitely dependent upon this independent quantity, and I hope you already know about the function from your mathematics course, but we will also see one example that will clear these things more. So let's say my function is f, and as it is dependent upon the independent quantity, and I will say my independent quantity is x, then I will write it as f x. This shows that this function is dependent on the x, and let's say it is equal to minus of a x square plus bx plus c. Now this is my function, and I will try to implement this function in a daily life example. For this I will take a boy. Let's have a boy, and this boy will do a work for us. He will go to a particular place and measure the temperature from morning 9 a.m. to the evening 9 p.m. So he's having his thermometer. He will stand there and he will measure the temperature in every 1 minute. So I can say he will have a data at the end of the day from 9 a.m. then 9:01, 9:02, like at 9 a.m. he is having 27 degrees Celsius, then 9:01 is having 27.5 degrees Celsius. In the same way, he will have the different temperature for different time till the 9 p.m. So this is his task, and he will have a data, he will have a list of the temperatures for a different time. Now what we can do with this information? We can plot it. So let's try to plot it. And you already know that this x-axis we use for the independent quantity, and this y-axis we use for the dependent quantity. And in this case, the independent quantity is time. Definitely the time is independent. I will represent it by small t, and this axis will represent my temperature. T, capital T, is my temperature, and as it is dependent on the time, I will write t here. Now we can plot these values. Let's say our origin is 6 a.m. and this point is 11 p.m. This is a 9 a.m. and this one here is 9 p.m. So we will just show the temperature for the different times, and let's say it comes like this, and then we can join these points and we will have our function like this. So this particular function is the downward parabola, and it is having the equation like minus of a t square plus bt plus c. This minus of a shows that we will have a downward parabola, and there is one condition for that. This a must be greater than 0. If this a is equal to 0, we will have a straight line, because t will be equal to bt plus c. This is the equation of a straight line, y equals to mx plus c. The c is the intercept, and if this a is less than 0, we will have the upward parabola. So this is a little bit about the functions. You have already learned these things in your mathematics back in the 11th standard, so we'll not go much into that. And finally you can have your signal. This function is your signal. You will have the values of the temperature for the different time, and that is what the signal. You will have a pattern that will tell you how the temperature has been changing from 9 a.m. to 9 p.m. So this is what you have to remember about the signals. Now I will narrow down this study of this signal, and I will talk especially about the electrical and electronics. And in electrical and electronics, usually the signal is the variation of the electrical quantity, generally current or voltage, with time. So it's important to write this thing, and let's write it down. In electrical and electronics, usually signal is variation. You can see here we are having the variation of the temperature with time. In the same way, we have the variation of the electrical quantity, and this electrical quantity is generally current or voltage. And what is the independent quantity in this case? The independent quantity is time. So this variation of electrical quantity, generally current or voltage, is with time. So this is something you have to keep in your mind. And there is one very important point that you must know. If the current or the voltage remains the same for different time, then it is not a signal, it is a direct value. For example, if I talk about the current, and if current is same for the different time, then it is direct current. It is not a signal, it is a direct current. And we can say di, the small change in the current, is equal to 0. The current is not changing, and you can plot it simply like this. The current at T1, let's say this is T1, is I naught, and current at T2 is also I naught. So the current is not changing, it is a direct value, and thus it is not a signal. Signal must vary with the independent quantity. And let's talk about the transducers a little bit. So the transducers are the device which is used to convert the non-electrical signal to an electrical signal, and the reverse transducer is the device that is used to convert the electrical signal to the non-electrical one. And let's see one example for it. If you are singing a song, you require a mic. This one is the mic, okay, and you are singing near to it so that your sound is converted to the electrical energy. This sound creates some vibration, and that vibration is converted into the electrical pulses, and that electrical pulses is amplified. There is a device that we call as the amplifier, because definitely it is required to amplify the signal so that it can be converted and interpreted well. So we have an amplifier, and once this amplifier is there, it will amplify, and then you have a speaker. The speaker is there, and then again the sound energy is given back. So sound energy is given in, it is converted to the electrical energy, it is processed well, and then again it is given back as the sound energy by the means of the speaker. So this is how the signal works, and it is a very small explanation for the signal. There are so many hundreds and thousands of types of signal available to us, and we have just saw one example for the temperature. Now in the next presentation we will see what is the analog signal and the discrete time signal. Then finally we can have our digital signal. So this is all for this presentation. See you in the next one.